This is the review for Earth Science, 7th grade, Weathering and Soil Formation, Unit 2, Chapter 4. All right, the very first thing we're going to talk about is weathering. And remember that weathering is the act of breaking down rocks. So it breaks those rocks down into smaller pieces. And so just remember that definition. What is weathering? Now, the next part, it has to do with the types of weathering, and one of those is mechanical weathering. Now, remember that mechanical weathering, that is the physical force, right? It's all physical. Does not change the composition, so composition stays the same. This is one type of mechanical weathering, and this is ice wedging. So water gets into the cracks, and then as it freezes, it expands, which causes the rocks to break apart. This type is called pressure release, and so there's gas that is trapped down underneath and inside the rock, and as it releases, it causes the rock to expand, which causes the cracks to form, and exfoliation can happen, and it breaks off in layers. Plant root growth can also cause weathering in rocks. So as there's a crack in a rock, a plant can actually take root there, and as it grows, it's going to expand itself, which is going to cause the rocks to break apart. If you look right here in the center, you can see that this tree is breaking the rock apart. The last type of mechanical weathering is through abrasion. There are 3 different types of abrasion that can happen, and it all involves water. So water wears down the rocks. It can also move rocks along, which can cause them to bump into other rocks, which is going to cause them to break down. And then also, like ocean waves, when they beat against the rocky shore, they're going to wear the rocks down through abrasion as well. Next up is chemical weathering. Now, chemical weathering, this is where the composition actually gets changed. You're going to see a change in the substances. And we're going to go back to composition. Okay, so when minerals in the rocks, when they contact air or water, you're going to get some that dissolves, but others react or change into different materials. Think back to the lab that you did where you changed the steel wool by giving it access to water. That is a chemical weathering because you have a change in composition. The rust was not originally there. It changed into rust. So water is the actual main cause of chemical weathering. So as we know, everywhere in our atmosphere there's small amounts of water, and that can actually combine with the carbon dioxide, and that can cause when those two react to form a acid, also known as acid rain. Okay, that slightly acidic water can break down those rocks like you see in this picture. So as you can tell in this picture here, this was taken about 100 years ago. This was a nice solid, see how all the lines are nice and crisp? But as of today, everything's been worn down, and this is worn down by that chemical weathering from that acid that happens. So back to rusting. So the oxygen in the air, right, it's involved in that chemical weathering because it's actually a combination that happens when the oxygen comes in contact with metals, then they dissolve in water. Oxygen in the air and the water combine with the iron to produce iron oxide, which is rust, which is what you see in this picture. These rocks actually will rust because they have that iron in them, and when it comes in contact with that oxygen and water, becomes that iron oxide. Weathering occurs at different rates, but it's going to change based on a few different things. The first thing is surface area. So how much of the surface is showing and how much of it is exposed to those weathering forces? The next is the rock composition. In rock composition, you're going to have different kinds of rock breaking down at different rates because things like granite are going to break down slow while limestone is going to break down fast because of their composition. And the last item is climate. So water is necessary for chemical weathering to occur, and heat speeds up chemical weathering. So chemical weathering is going to occur faster in hot, wet regions, while it's going to occur slower in cold, dry regions. On the other hand, mechanical weathering is going to happen more often in cold regions than in hot regions because of freezing and thawing. Now let's talk about soil. Okay, so soil is a mixture of weathered rock and other materials. So most soil comes from 4 different materials. So we have weathered rock, organic matter, and water and air. Now, weathered rock is going to vary on its size, right? Some's going to be sand, some's going to be pebbles, but this actually makes up the majority of your soil is weathered rock. Now, about 5% of soil comes from organic material. Now, remember, organic matter means to come from something living. So this is decomposed animals, plants, and other living organisms, so that they actually compose about, again, 5%. One other thing about organic matter is to remember the word humus, or humus, and this is the decayed organic matter that is in soil. That's actually what the organic matter is called. And the composition of soil is about 20 to 30% water and air. All right, now soil actually has different layers, and what we call these is soil horizons. Now remember, there are horizons A, B, and C. Okay, so let's talk about these horizons. So here is our A layer. Now A layer is the upper layer of the soil, which we also commonly call topsoil. It has the most organic matter, and because of the humus, it is often dark in color. Now B, which is this one down in here, this is the one that obviously lies right below the A layer, has little organic matter, and it's normally brownish or reddish, and it contains the clay and minerals that have washed down from the horizon A. And the last one is layer C, and this is down the farthest. It's the deepest layer of soil, and it has the largest and least weathered rock particles. So this is where you're going to typically see things like the pebbles, and it's typically a light yellowish brown color. Climate affects soil, right? So soil that's formed in hot, wet climate is going to be different from that in a cold, dry climate. It influences the characteristics and thickness of that soil, which because of the development of weathered rock. Okay, if we take a look at this picture, you're going to see that there are 4 different types of soil here. You have tropical soil, desert soil, temperate soil, and Arctic soil. Now, each of these has different compositions because of the different climates, right? So tropical soil comes from a warm, rainy region, and the heavy rains wash away the minerals. So you're going to only have a thin surface layer of humus, and they are not suitable for growing most crops. Desert soils, again, from dry regions, just like the ones we have here in Nevada. They're shallow, contain little organic matter. Because we have low rainfall, chemical weathering and soil formation occur very slowly. In temperate soils, these form in regions with moderate rainfall and temperature. These are great crop areas. Some are dark color, rich in organic minerals. And then our last one is Arctic soils. They form in cold, dry regions. Chemical weathering is slow there. They do not have the developed horizons that we talked about, those A, B, and C horizons, and they contain a lot of rock. Two other things affect the soil, and one of those is landforms, such as if we have a mountain, right? So what's going to happen here, you're going to have a difference between the soil up here and the soil down here, because when the rains come, it's actually going to wash the soil down the mountain, causing a high amount of A horizon soil down at the bottom and very little A horizon up at the top. So you're not going to get a lot of plant life up here, but you're going to get a whole lot down in here. And the other thing that can affect soil is organisms. Okay, organisms are going to get into the soil. They're going to build different burrows. They're going to grow their roots, things like that. And it's going to change how the soil goes from layer to layer, and it's going to aerate the soil. So they can actually have a big effect on the soil as well. There are 4 properties of soil, just like we've talked about properties of just about everything else. There is texture, color, pore space, and chemistry. Now, a few of these you just worked with in the experiment regarding soil, so let's talk about each of them just briefly. Okay, the first thing is the texture, and there are 3 different types here. There's sand, silt, and clay. These categories all depend upon the size of the rock that has weathered inside, and they are actually going to influence how air and water get through the soil. Okay, a couple of things regarding color. So color, most are going to be red, brown, yellow, green, black, and even white. The color mostly comes from iron compounds and humus. And the color can actually indicate the content of the soil, but it also can indicate how water moves through it. Bright colored soils are going to drain well. Okay, now pore space. Now we've talked about this a little bit, especially in the lab that you did. Pore space, it refers to the space between the soil particles. You got to have space between those particles in order to get water and air through, and plant roots need that water and air in order to grow. So most soils are going to range anywhere from 25 to 60% of pore space, and at about 50% of pore space, you're going to have the best pore space for growing plants. And the last section is chemistry. So plants absorb the nutrients they need from the water that's in that soil. So in order to be able to get that nutrient, they need to have a soil that has the right combination of nutrients in it. Well, the water's pH, written little p, big H, is going to allow, depending on the level of the pH, is going to allow the water to dissolve, or the nutrients to dissolve in the water, either better or poorer. And so that's why the chemistry of the soil is so important. All right, so the next section is regarding soil use and conservation. So how can we make sure that our soil is around for many years so that we can continue to use it? So the way that we use the land can affect the levels of the nutrients and the pollution in the soil. Okay, farmers add fertilizers. Now this helps their crops grow better and maybe gets us better crops. However, the problem is these can actually kill off microorganisms and can lead to problems with water pollution when the rainwater runs through and gathers it. Another way that farmers can affect our soil is through soil loss. So what happens here is the soil is damaged when the farmers remove the plants and the trees in order to allow their crops to be planted, which can actually cause the rainwaters to be able to wash away the soil. And the last way that farmers affect this is through overgrazing. Just like when the farmers remove the plants and the trees, when they allow their cattle and other animals to graze on the land, it pulls up those plants, which again is going to expose the soil to wind and water and wash it away. Okay, construction and development. Just like when those farmers remove the plants, well, they do that too when we're doing construction and development. They remove the plants, allows the soil to again be washed away or blown away. Also can cause problems because those soils can actually make it into rivers and lakes, and it harms the organisms that live inside them. In the last unit, or the unit before actually, we had learned about mining. Mining also causes problems for our soil. So when we dig strip mines or open pit mines, you have to remove the plants and soils from the surface, and that again is going to allow those soils to be washed away. Okay, so conservation of soil is also very important because once the soil has been removed from an area, it can be very difficult to put it back. Now there's different methods that are designed to hold the soil in place and to keep it fertile. We're going to talk very briefly about 5 of them and then a little bit more about 2 of them. So mostly I want to list them. So there's crop rotation, conservation, tillage, terraces, contour plowing, and windbreaks. Again, there's really just these 2 that I want to talk about though. So in crop rotation, you're going to have farmers that are going to practice planting different crops on the same field in different years or growing seasons. So grain crops such as wheat, they use up a lot of nitrogen in the soil, right? And plants need that nutrient. It's a necessary nutrient. So root crop or other crops such as beans or soybeans contain a bacteria that restore that nitrogen. So what happens is the farmers are going to rotate these crops. They're going to put in their grain crops like wheat, and then the next year or maybe a couple years down, they're going to go ahead and put in some bean crops, which is going to put that nitrogen back in the soil, and that allows the soil to stay healthy and fertile. And the last one is conservation tillage. Now, in conservation tillage, they're going to reduce the number of times the fields are tilled or plowed in a year. So this allows the soil to be disturbed less by the plowing, which is going to cause it to not be washed away or blown away as often. Some farmers even don't till or plow at all. They allow the leftovers from the previous harvest to become a protection on top of the soil, and new plants are just planted within that same soil and root up through the old plantings. That ends the chapter review for this unit, and as always, good luck and happy studying.